Let's talk about exceptions and exception handling in Python. You see, there are certain errors that Python will identify during the compilation itself. One such example is the syntax error. Let's see an example. So when I say print, and I'll simply write the string and I will not enclose the parenthesis. So this is the syntax error, right? So this will be identified by Python in runtime itself, saying unexpected EOF end of EOF while passing file or while passing. So but there are certain errors that Python cannot identify like this during the compilation time. They can only be identified during the runtime, and they are called as exceptions. Let's see an example. Let's define two numbers a equal to 5 and b equal to 0. Okay, I have two numbers 5 and 0. When you try to add these two numbers, the result is equal to 5 plus 0, which is 5, right? So I'll store it in one more variable and I'll simply print addition equal to C. So this gets executed with no problem at all. But when you try to divide these two numbers, let's assume when you're doing the division a divided by b and division equal to c, let's see what happens. So we can see that Python has thrown an exception of the type 0 division error, and the program has stopped abruptly. The reason I said abruptly because the very next statement, which is the print statement, did not execute and the program just terminated when it found an exception. So this is where something called exception handling has to be done to our programs so that such kind of unexpected exceptions should not terminate our programs abruptly. The simplest and easiest way of handling any type of exception that may occur in our program is by just enclosing our program inside the try and except block. So here's an example, and inside try let me define two numbers 5 and 0, and let me try to divide those two numbers and print the result as well. Okay, except, and if there is any exception I'll say some error occurred. Okay, when I execute this, even though exception occurred in our program, it has been handled and it has been terminated in a proper way with some message instead of simply terminating abruptly. Okay, so now if we just write except, then you're using the base class of the exception, which is capable of handling any type of exceptions that can occur in our program, and print a generic message. Okay, but we can also handle exception of specific types, or also called as the child exceptions or child class of the exception, to provide meaningful messages. In our example, we know that we will be getting a 0 division error when we try to divide a number with 0. So we can make use of this child class exception. Okay, so let me write here. So instead of except using using the base class, I'll write a child class 0 division exception, 0 division error. I'll say zero division error occurred in the program. Okay, so now we can, with the help of these child exceptions, you can print a meaningful message when the program goes into exception. So now this program works fine, but I would like to inform you that our program can handle the exception of type 0 division error only, which means that if there is any other type of error, the program cannot handle it. For example, let's assume if we are trying to divide a number with string. Okay, we know that we cannot divide a number with a string, right? So it will throw a different type of exception this time, and that exception is not 0 division error, 0 division exception. So it is not being handled in our program. So you will again get an exception saying unsupported operand type, integer and str. Okay, so it is always in this case it is type error exception which was not handled on our program. So it is a good practice to also include the base class of the exception, so that if there is any other type of exception that we think can be possible, we will still get a user friendly message. So I'll write except, and we know that this is the base class, we are not writing any child class exception here. I'll write a generic message, some error occurred. So this way we handle any type of exception that we think we would not have expected. Okay, also please remember that you write this base class exception code after writing all the child classes. Okay, so because if you write the base class exception first, for example if you do something like this, you write the base class first and then if you write the child class, you will first, it will catch the base class first and will not even check for the child class. Okay, so to avoid this confusion, Python will throw an invalid syntax during the compilation error to avoid such type of coding. Okay, it will throw a syntax error if you try to do such kind of coding. So ideally you should write all the child exceptions first and then finally you have to write the base class or the parent class exception message or the code. Okay, also Python provides an option for you to raise an exception manually by using the keyword called as raise. So let's see a simple example to do that. So I'll say try. In try I will simply raise 0 division error. I am manually raising, even though I'm not dividing any numbers by 0, I'm manually simply just raising the 0 division exception. Okay, and now in the except, I'll just copy from the previous code. So I'm handling the exception. So with this raise keyword you can manually raise an exception of any type you want to. Okay, so even though we are not dividing any number by 0, we can still raise any type of exception using the raise keyword. Okay, now let's talk about the try, except and finally block. Now that we know that whenever there is an exception in our program, the normal flow of the program gets changed, but there are certain scenarios where certain action has to happen whether there is any exception or no exception. So let's assume we are trying to open this text file, and we are trying to open this text file and read all the contents. So after reading all the contents we have to close the file. Okay, so let's write a simple code to do that. So I'll say file equal to open my file dot txt, and I'll open it in the read mode, and I'll say for line in file I'll simply print that line. And after reading all the lines or printing all the lines, it is very important that I close this file. Okay, so it is very important to write this file.close, because so that we release the resources that from memory. Okay, so let me execute this. Okay, my file.txt. Okay, so we read all the file and it got closed. Now let's assume while you're reading the text file, some error or some exception occurred and the program terminates abruptly without executing this last line, which is file.close. Okay, so how do we tackle that problem? One option to tackle such a situation is to make use of the try and except block. So I'll write try, and inside try I will write this code. okay, and then except. So even if there is any exception in our program, we will still try to close the file. Let me execute this. So this is one way, but if we observe what we have done, we have written file.close both in the try block as well as in the except block. This is where something called finally block comes in handy. Let's see an example. So in finally block, you don't have to write the file close every time. You just so in except, I'll just simply print some error occurred, and in finally block I'll write file.close. So the code which is written inside the finally block will get executed whether or not if there is any exception or not. So there is no need to write the file.close in the try as well as except block. If you just mention it in finally block, it will get executed. Okay, so whether there is an exception or there is no exception, it will still execute this code file.close. Okay, so that's all about exception handling in Python.